Hello everyone. So today we are going to learn the basic concepts and tricks associated with a chapter called clocks. Now clocks is something which has been asked in practically every exam, in every law entrance exam, or in fact I would rather say in every aptitude exams you would find questions based on clocks. So we would be taking up this chapter in two parts, and today's session we'll be looking at the basic concepts. And let me first tell you what kind of questions are being framed on clocks. So the types of questions which are framed on clocks or which are asked on clocks are like, first kind is finding the time when the angle between the two hands is given. Second variation is finding the angle when a particular time has been given and we are supposed to find the angle between the two hands of the clock. Now, the third kind of questions are error. There is some error in the clock, whether the clock is gaining time or losing time. So there are questions based on that. And there are questions on the mirror and water images. So we would be looking at each kind of questions one by one with sufficient examples. Firstly, we would cover the basic concepts and theory associated with clocks. So let us first understand the concept behind the clocks. Now clock, as we know, if we talk about the geometrical shape, the clock has to be a circle. It is circular in shape. And we know we are talking about an analog clock here, not a digital clock. Analog clock where we can see the different hands. Okay. Now we know there are three hands in a clock, which are, there's an hour hand, then we see a minute hand and a second hand. If you have noticed an analog clock, you can see all these three hands sticking together at the same time. Okay. Now, when we talk about clocks in respect of our exams, most of the work is related with hour hand and minute hand. Second hand is actually not required. So we would be only talking about two particular hands here, hour hand and the minute hand. Okay. Now, before jumping into the minute hand and hour hand, we also need to understand there are 12 divisions in a clock, which you can see starting from 1, 2 and then going forward to 12. Now, since it's a circular in shape, the entire rotation in terms of degree happens to be 360 degree. And we have 12 divisions on clock. So, each division is of 30 degree. In fact, the movement from 12 to 1, or we could also say, a clock has 60-minute spaces. We can also talk in reference of minute spaces. So when somebody moves from, or when the hour hand moves from 12 to 1, we can say it has covered 5-minute spaces. So a couple of times we will also be talking in reference of minute spaces, and a couple of times we will be talking about in terms of degree. Now, to understand this chapter of clocks better, we need to understand what is the movement of minute hand and hour hand. Now we can easily compare the movement of minute hand and hour hand, which are continuously moving around a clock, to the situation where you can see two runners running around a circular track. So whenever we see people in motion, we talk about their speed. The concept of speed comes into the picture. Usually when we talk about the human beings or the vehicles going around, the speed happens to be in terms of kilometer per hour or meter per second. Here the speed has to be in degree per minute. Let's find out the speed of minute hand and hour hand. Now we know the minute hand completes one full rotation, that is starting from 12 and again coming back to 12. This is traversed by minute hand in 60 minutes. So for minute hand we can say that in 60 minutes it covers 360 degree. So in 1 minute it will cover 6 degree. So we would say that the speed of minute hand is 6 degree per minute. This is something that you need to retain. This is something that you need to remember when solving clocks questions. Now coming to hour hand. If hour hand is at 12, it would take another 12 hours to come back to 12 or to come back to the same position. Okay. So we can say our hand completes one full revolution around the circle in 12 hours. So we could say in 12 hours the hour hand rotates 360-degree. When I convert hours into minutes, so we can say 12 into 60 minutes is taken by our hand to complete 360-degree. So in 1 minute, the distance traveled by our hand comes out to be half degree. So the speed of our hand would come out to be as half degree per minute. Again, something that you need to keep in mind. Now, if you recall your chapter of TSD, whenever two things are in motion, the concept of relative speed comes into the picture. Here, the hour hand and the minute hand are continuously moving. So, we need to talk about the relative speeds. And when objects are moving in the same direction, the relative speed is nothing but the difference. So, the relative speed of hour hand and the minute hand here happens to be 6 minus half. So, would come out to be 11 pi 2 degree per minute, or you can say 5.5 degree per minute. So in every minute, the minute hand is gaining 5.5 degrees over the hour hand, because we know minute hand is the faster hand out of the two hands. So these are the three things that you need to keep with you whenever you're solving clocks questions: the speed of minute hand, the speed of hour hand, and their relative speed. Moving forward, here we will derive the ideal time after which the hour hand and the minute hand should meet. Here we know speed of minute hand is 6 degree per minute, speed of hour hand is half degree per minute, and what I'm trying to find out here, or what we are trying to find out here, the time after which the both hands will meet. So we know they were together at exactly, let's say, 12 o'clock, and within the next minute, the minute hand has gained a lead over the hour hand. Now, this is a case of circular motion. In order that minute hand will again meet the hour hand, the minute hand has to complete or has to gain one full rotation over the hour hand. So that's why we know time is distance upon speed. So time after which the hour hand and the minute hand should meet would be given by distance between hands upon the relative speed. Now here the distance to be traveled in order to meet is nothing but the one full rotation. That's why the distance will become 360-degree and the relative speed is 11.5 degree or 5.5. So this comes around, when I solve it like this, this comes around 720 by 11, and if I convert into mixed fraction, it is 65 by 11 minutes. Now, this is the ideal time for a very correct clock, and if we can say that if both the hour hand and the minute hand move at their normal speeds, they will meet after every 65 by 11 minutes. This data is very important. There are a few kind of questions. In order to solve them, you need to have this data with you. If you don't have this data with you, you cannot actually attempt those questions. Now let's discuss the type 1 kind of questions, which are finding the time when the angle between the two hands is given. Okay. Now there are multiple methods to approach this. So I have discussed all the possible methods in which this question can be done, and then you can figure out which particular method works better for you. Okay. So here we have a question: at what time between 4 and 5 will the hands of the clock coincide? So we will start this question. The method 1 is talking about the relative speed. We will start this question by looking at the scenario at exactly 4. At 4 o'clock, this is the hour hand. Hour hand is exactly at 4, whereas the minute hand is at 12. Angle between them is 120 degree. We know each division is 30 degrees, so there's a difference of 4 divisions here. The angle should be 120 degree. Now, in order for them to coincide, we want the hands to coincide. In order for them to coincide, What actually has to be done here? The minute hand has to travel this distance of 120 degree and come to hour hand. Okay. Now we know time is given by distance upon relative speed, because here both the objects are in motion. That's why we are talking about the relative speed. A distance to be covered by minute hand. In order to meet hour hand at the beginning, the distance to be covered is 120 degree, whereas the relative speed is 11 by 2 degree per minute. So this comes down to 240 by 11. When we convert this into mixed fraction, this comes out to as 21/9 by 11 minute. So we can say that the hands of the clock will coincide at 4:21/9 by 11 minute. So here we have solved this question using the concept of relative speed. Okay. Now we have a direct formula also to approach these kind of questions, and that formula is theta is equals to 11 by 2 m minus 30 h, where theta stands for the angle, m stands for the minute, and h stands for the hour. Now the question which we have done earlier, we will take the same question here. Our question was between 4 and 5 p.m. at what time the hands of the clock will coincide. First of all, we are talking about between 4 and 5 p.m. We want the hands to coincide. So theta between them should be 0 degree. And we are supposed to find out the value of m here, because we want the exact time at which they'll coincide. So putting these values in this equation, theta is equals to 0. We are supposed to find m here. The value of h has to be taken 4 here, the lower angle, the lower r rather, okay, the lesser value of r, because my answer has to be between 4 and 5 p.m. So it has to be 4 o'clock and then certain minutes. So h has to be taken 4 here. We get 120 is equals to 11 by 2 m. We again get m as 240 by 11, as we have seen in the last question, which is 21/9 by 11 minute. Now there are few standard angles, okay, which are being created multiple times during the day, okay, and those standard angles are 0 degree, 180 degree, and 90 degree. So we'll do a bit of discussion over here. Now when we say the angle between the hands is 0 degree, we essentially means the hands of the clock are together. Now if you observe your analog clock, you would see that in every hour the hands of the clock will meet once. So we can say here that in every hour the hands of the clock will meet once. So in 12 hours, ideally they should meet for 12 times, but no, the answer happens to be 11 times. Let's understand why the answer is 11. Now the exception, let me call this as an exception. The exception happens between 11 and 1. Why? Let's see here. If we say this is the scenario at 11 o'clock, minute hand is already ahead of hour hand, and as and when the time starts moving ahead of 11 and it starts moving towards 12, minute hand is rotating in the clockwise direction, even the hour hand is rotating in the clockwise direction. They would meet at exactly 12 o'clock. They would not meet anywhere in between 11 to 12. In fact, they would meet at exactly 12 o'clock. Okay. And immediately after 12 o'clock, again, the hour hand, if 12 o'clock they both are here, again after 12 o'clock the minute hand is faster. It would start moving at a faster pace, and by the time 1 o'clock happens, hour hand is at 1, whereas minute hand is at 12 only. So they have not met so far. They have not met between 12 and 1. So these 2 hours is an exception hours. Okay, so between 11 to 1, they will meet, or the hands will meet at exactly 12 o'clock. That's why in 12 hours they'll meet for 11 times, and if it is being asked for 24 hours, then the answer should be 22 times. Similarly, 180 degree. Now 180 degree is when the hands of the clock are exactly opposite to each other. Same as same as 0 degree. In every hour, hands of the clock will be opposite to each other once. So in 12 hours, answer is again 11 times, not 12 times. Why? Because again we have an exception. Here our exception is 5 to 7 p.m. Let's understand this. The scenario at 5 o'clock is that our hour hand is at 5 and our minute hand is at 12. Okay, minute hand is behind the hour hand. So between 5 to 6, the minute hand, the one who's traveling faster, will come and overtake an hour hand and move beyond towards, it will again move towards 12. By the time minute hand and hour hand comes into a straight line opposite to each other, it is exactly 6. At exactly 6 o'clock, they are exactly opposite to each other, making an angle of 180 degree. And between 6 to 7, what would happen between 6 to 7? At 6 o'clock, this is the scenario. At 7 o'clock, our hand is here. Minute hand is again, travel from 12 to 12, but they have not come in a straight line. Okay, they would not make an angle of 180 degree. So again, between 5 to 7, we observe that it's only at one time that the hands of the clock are making an angle of 180 degree, and that is happening at exactly 6 o'clock. So that's an exception hour, that between 5 to 7, the hands will be opposite to each other only once at exactly 6 o'clock. So that's an exception hour. Okay, so in 24 hours, the hands will be in opposite direction for 22 times. Okay, now another standard angle is 90 degree when the hands of the clock are at 90 degree. Now here, what you need to understand, as we have seen with the case of 0 degree and 180 degree, that those angles can only be formed once in an hour. 90 degree can be formed twice in an hour. Okay, so hands of the clock can be at right angles twice in an hour. So in 12 hours, answer should have been 24, but that is not the case here. Okay, answer here is 22, because there are two exception hours. The two exception hours are 2 to 4 and 8 to 10. Between 2 to 4, they should have met for 4 times, but they meet only for 3 times, or not meet, rather they make an angle of 90 degree 3 times. Similarly, between 8 to 10, they should have made an angle of 90 degree 4 times, but we see that an angle of 90 degree is only created 3 times. So the count of 24 is decreased by 2, and it happens that we can say that in 12 hours they are making an angle of 90 degree 22 times. Let's understand these exceptions. How are these exceptions coming up? So between 2 to 4, and why are we saying that the angles or an angle of 90 degree can be created twice in an hour? It can happen so A 90-degree can be created when the minute hand is 90-degree behind the hour hand, and since it is moving at a faster pace, it will cross the hour hand and goes beyond the hour hand, and again an angle of 90-degree can be created. Okay, so let's have a look at what is happening between 2 to 4. Now, the scenario at exactly 2 is this. This is the hour hand and this is the minute hand. We know minute hand is 60-degree behind the hour hand, and they both are moving in the clockwise direction. So minute hand is moving faster towards this direction, and it will come to hour hand and cross it, or it will cross or goes beyond the hour hand. So there would come a scenario when it will cross the hour hand. There would come a scenario at a particular time that there is an angle of 90-degree created between the hour hand and the minute hand here. There would be one particular instance that an angle of 90 degrees created, and another 90 degree is created at exactly 3 o'clock. So we can see here the first 90 degree is created somewhere between 2 to 3 p.m. The second 90 degree is created between or is created at exactly 3, and the third 90 degree again at 3 o'clock. What would happen? At 3 o'clock, minute hand, hour hand. There's an exact angle of 90 degree between these two hands. And as we move beyond 3 o'clock, the angle of 90 degree would be reduced. The minute hand will overtake the hour hand in some time and move beyond. So again, somewhere there would come a particular instance that an angle of 90 degree would be created. So third 90 degree is created somewhere between 3 to 4. And then another 90 degree is not created before 4 o'clock. By the time 4 o'clock happens, the hour hand is here and minute hand is again back at 12. So there's no opportunity or no place where another right angle is being made by the hands of the clock. So we see in these 2 hours between 2 to 4, the 90 degree angle is being created only thrice in place of 4. The same phenomena we can say happens for 8 to 10. Okay, where again this first 90 degree is created between 8 to 9. The second 90 degree is created at exactly 9 o'clock, and the third 90 degree is created between 9 to 10. So these two time periods are the exception hours for 90 degree, and that is what you need to keep in mind. So I've tabulated all this information in a table. I think that would become much easier for you to understand. Let's have a look. So here, if you can remember this table, these kind of questions are an oral thing, will become an oral attempt for you. You don't even have to pick your pen and solve this. So 0 degree in 1 hour created for 1 time, in 12 hours 11 times, in 24 hours 22 times. Exception 11 to 1. 180 degree in 1 hour 1 time, in 12 hours 11 times, in 24 hours 22 times. Exception are 5 to 7. 90 degree in 1 hour it's been created 2 times, but in 12 hours it's been created 22 times, in 24 hours 44 times. Exception hours between 2 to 4 and between 8 to 10, as we have just seen a while back. So just make sure that you have this table somewhere registered in your mind, and these questions would become really easy for you. Now we also have some additional formulas to find out these standard angles. For example, if we want to find out the time at which the hands of the clock are together between, let's say, 5 and 6, so we can use the first formula here, and our time would be given by 12 by 11, and we are talking about 5 and 6. So our initial hour has to be 5. So this comes around 12 into 25 by 11, and this comes around 300 by 11, and when I convert this into mixed fraction, this comes around 27 3 by 11. So we can say at 5:27 3 by 11 of the time, the hands of the clock are together between 5 and 6 p.m. So we have a formula to find out when the hands of the clock are opposite to each other. This is the formula for that. Now, as I've shared earlier, an angle of 90° can be created twice in an hour. So let's explore this between 5 and 6 again. That what are the two times that the hands of the clock are at 90°? So for the first time, we'll use the plus 15. So formula would be like 5 into 5, 25 plus 15. This would give us the first time. And the second time would be given by 25 minus 15. So this comes around 20. This is 480 by 11, and the second times comes around 120 by 11. Converting them into mixed fraction, we see that it comes around 43 7 by 11, and the second time comes around 10 10 by 11. So the two times at which the hands of the clock will make a 90° between them and between 5 to 6 p.m. would be 5:43 7 by 11, and the other time is 5:10 10 by 11. So if we use these formulas, there's not going to be any confusion if you remember these formulas. So in the next session, we will be looking at the kind of questions where a particular time has been given to us and we are supposed to find angle between the hands of the clock. We will also be looking at the questions where there is some error in the clocks, as in the clock is gaining time or losing time. And additionally, we would see how to approach the mirror and water images questions based on clocks. Till then, take care. Bye. Thank you.